Hi everybody, welcome back to 1/16 scale RC. Today I'd like to do a short video just explaining some detail around my recent conversion of the Bruder Schaeff HR16 model. What I'll do is I'll just bring the truck into view on the camera so you can all see the vehicle that I'm actually talking about. Okay. So that's the little beast there, as I call it. What I'll do is I'll run through the function of it as it stands at the moment. Once I've done that, what we'll do is we'll get into the nitty gritty. I'll take the back cover off, show you what's inside, run through some of the options I used for the cab rotation, the drive function and the articulation on the arm. So first of all we'll have a look at the cab rotation. So it's a motorised cab. It runs on a 100 RPM N20 geared motor. It's got a nylon gear wheel and a ring gear fitted to the bottom of the cab. So as you can see, cab rotation is quite smooth. It will rotate a full 360 in either direction, as you can see. Goes around quite smoothly in both directions. And I'm quite pleased with the way that's worked out. The reason I'm pleased I'll explain in a minute when we get into the workings of things. There were some challenges involved in doing that, and believe it or not I wouldn't recommend, if you attempt one of these, that you do it the way I've done it, and I'll explain the complications and the reasons why I say that in a minute. So that's a cab rotation. We've got dual servos for the track drive. These are continuous rotation servos, i.e. 360 servos. They're the same size as your SG90s, so fit quite nicely into a model of this size. And I use the sticks to control them, so you can have good turning in either direction by forward and rotating in reverse the opposite track. So it's quite easy to steer, quite nice to drive around, to be honest. Okay. The arm articulation, I've used again N20 motors. These particular ones are the M4 threaded variety. They are both 300 RPM motors. I chose the 300 RPM motors purely because I wanted to keep the arm articulation relatively in scale with the truck. I didn't sort of want to wait 10 minutes for the arm to extend out and 10 minutes for it to retract back. I want it to move quite fluidly, quite quickly, in order to make the truck look fairly realistic. And I think you'll agree that the movement action is actually quite quick when it needs to be. Obviously these are controlled by ESC, so you can slow or speed them up, and they do move in and out quite well, to be fair. There's a couple of challenges I faced in using this setup, and again, once we've had finished looking at the actual operation of the truck, I'll run through with you what those challenges were. We've finished having a little look at the operation of the little machine. What I'll do now is I'll remove the battery, turn everything off, and hopefully we can get in a little bit closer and have a look at what I've done with the actual conversion side. So the battery is located inside the back housing. And that unclips and lifts off fairly easily, as you can see. The battery is a 2S 6.6 volt LiFe or LiFe battery, and it slots quite nicely into the back of the truck there. Although you can see there's no space, there's no movement, everything is in quite tight, it's all compacted in there quite well. The battery slides out quite simply, like so, and then all I do is disconnect at that point. I didn't actually fit a power switch in, and I'll show you the little battery just so you can see the type that I'm using. I haven't fit the power switch in this purely because of space, again, somewhere to locate it where it's easily accessible and not in the way of everything else, because simply, as you can see, everything is quite well packed in the back there. We've got the ESC's for the motor control laying in the bottom of the compartment, in the lower section there. The receiver is literally sat in on top. These are the antennas, as you can see. All the relevant wiring plugged in, so all the ESCs, etc., plugged into the receiver ports there underneath. And then, as you saw, the battery slides in on the top. So it's very compact, and you really do have to maximise the space that's available in there in order to get everything inside. Really quite challenging to do. The things that I didn't do on this truck in terms of RC control, if you like, the little blade shovel on the front there, I've seen them on YouTube videos with this in operation where it will actually go up and down. I decided not to go for that option, purely because the truck itself is extremely lightweight. There's next to no weight to it at all, so it has really limited pushing power in terms of its capability. So with the blade down, it may be able to lightly push fine sand or light dirt. It's not going to do a great deal before the tracks start to slip and you lose the momentum, to be honest. Because of that, and obviously because of the limited amount of space, I opted not to have that function operational. Some people do. It does look very good when it is functioning, but again, to me, for the amount of mileage I was going to get out of it, it was just too complicated to do and too restrictive in terms of space. The other thing that I didn't do, the arm at this point here will rotate left and right, and I've seen people utilise this little arm here connected to a servo to allow that function to happen. Again, maybe their internal layout is slightly different to mine, maybe they had a little bit more space they could utilise. I decided not to go for that option purely, again, as a space saving issue. I think people tend to do them getting to the point where they start compromising the inside of the cab, where you start losing some of the detail in there and there's certain electronic components are visible. Again, I wanted to keep the truck in as much of an original state as I could. Didn't want it to look too obvious. Certainly wanted to keep the cab intact. Wanted the driver sat in there for a bit more detail, a bit more realism. So again, that's another reason why I didn't opt to do that. In terms of function of the arm, a common way that this is achieved is by integrating servos actually into the body of the arm and using linkage rods from servo horns up to the various pivot points. Again, although this is very functional, does work well, I've seen them on, again, YouTube working, and people seem to have great success with them. For me, it wasn't the option I wanted to choose, purely because I don't like the visibility of the servos. It doesn't look natural, it doesn't look real to me. These things are hydraulic, they do have hydraulic cylinders and rams. I wanted to try and incorporate that into this build. I wanted to look as original or as natural as possible. So purely because of that, that's the reason I opted to use this method over the servos. In terms of the components I used to carry out the RC conversion, if we start at the lower section, the track area, work our way up through the drive motors to the cab rotation motor, and then up to obviously the arms and the way I did those. If we look at the underside of the truck, and I'm hoping this is going to be visible for you guys on camera. Unfortunately, my lighting isn't brilliant. I'll try and bring a bit of light into the shot if I can. If you just bear with me. Hopefully it will make things a little bit more visible for you guys to be able to see what's going on. I think that's going to help. So to start off with, I've got a little bit of tape just holding the wiring up there at the moment. I'm going to hot glue this in at some point. Again, I've got distracted, I haven't got round to doing it, but it's something that is in my plan. What I've actually done is we've got two continuous rotation servos mounted in here back to back. They're basically the same size as the SG90 servos, the only difference being, as I say, they're continuous rotation, so you get the full 360 turn on them. I 3D printed a little mounting plate for them. and they drop in on these little blocks either side here, and I screwed through from the outside. That locks the two servos in back to back, and they worked out pretty much just right for the width of the chassis, so they're quite easily incorporated into the overall chassis size. On the end of those, I've got the circular servo horns that come along with the servos when you buy them, and on the end of those, the gear wheels or the drive wheels, which are these two on each side, are fitted onto the ends of those discs. Originally I glued them in position. They didn't seem particularly strong to me. I had a few issues with a couple of occasions where one's come away and I've had to try and reposition it and reset it. So to combat that, what I did was I drilled through the outer housing, and you can just about see inside there. I fitted the little servo horn screw through direct into the circular disc on the servo horn, and then down into the servo body itself, just to make sure these stayed in position. I didn't want them coming apart every 5 minutes and having to reset them and reposition them and all the associated grief that goes with doing that. So I think that was a better option. Okay, so from a drive point of view, very, very effective. Don't have any issues with the servos playing up. Get good positive drive on the tracks. Machine seems to operate quite well. On flat surfaces, sand, loose gravel, it tends to hold its own. Haven't had any issues yet of it getting stuck or bogged down, for want of a better way of looking at it. In terms of the cab rotation system, basically what we have is sat in the back there, as you can just about see, is an N20 100 RPM motor. This is mounted vertically and fitted into a little housing which you can see is screwed in position there. On the end of that motor shaft there's a small nylon gear wheel, and I was quite fortunate. Many years ago I had a couple of little RC helicopters, and they were broken down over the years for various parts, and I was quite lucky to have a ring gear available that fitted the underside of the cab there perfectly. You can just about see the teeth of it behind the nylon gear wheel there. And they lined up and synced together pretty much spot on. That's what allows me the cab rotation. It makes it a very smooth action. However, having said that, on reflection and hindsight being a wonderful thing, it's probably not a method I would use if I were ever to do this build again. The issue I faced was with the motor mounted in its vertical position like that. If I can turn this over slightly, you'll be able to see the motor protrudes down through, or the motor housing protrudes down through the bottom of the truck there. In its original format, that motor housing was hitting the ground beneath the tracks, and I had to come up with a means of raising or lowering the tracks down for that motor to be able to clear the underside of the truck, or the underside of the ground on the bottom of the truck. The only way I could do that was to completely remove these two sections off each side and to lower them. And to lower them, what I did was I made two right angle aluminium brackets, brought them to the original chassis, then repositioned these side motor housings onto that aluminium frame and lowered them down to give me that motor clearance underneath. It works fine, but at the end of the day it seemed a lot of work which could have been avoided had I used a different system to rotate the cab rather than a motor system and a gear wheel. You are limited in options. As you can see, there's a small round hole in the bottom there that goes up into the bottom of the cab. This is a point where the cab rotates on. It's a clipped assembly. I don't know if you can quite see the clips up inside there. So you're limited as to where you can mount a servo or how you can mount a servo if you decided to make the cab rotation via servo operation. Again, it's a difficult decision to come to. I went with the motor version. Hindsight, I probably wouldn't do that again. You guys, I'm sure, will come up with alternative methods or alternative ways of doing it that suits your own needs, to be honest. But I wouldn't say don't do it this way. Just be aware there are pitfalls in terms of these track elevations on each side and the clearance on the motor. So we've looked at the drive method for the tracks, we've looked at the cab rotation system. The only thing really left to go through now is the method of the arm movement. What I decided to do, as I said earlier, I wasn't a big fan of the servo mounting incorporated into the arm setup. I didn't like the wires coming from the servo horn up to the pivot points up here. They looked too obvious. Although they, as I said, they function well, it really wasn't a method that I wanted to use. For me, these trucks are based on hydraulic vehicles. Hydraulic vehicles tend to have cylinders and rams, and although these aren't hydraulic, I did want to try and incorporate something that looked similar into the build, into the design that I was doing. So what I decided to do was I'd use two 300 RPM N20 motors. The reason I've selected that speed was I wanted fluid and quite rapid movement on the arms, as you would expect to find on the real vehicle. I didn't want to be sort of waiting 10 minutes for the arm to travel back in towards the body with a bucket load of sand. Wouldn't be realistic, wouldn't be practical, wouldn't be enjoyable to use at the end of the day. So the motors I've selected, as I said, 300 RPM N20 with the 4mm threaded section already fitted onto them. This is quite useful because that will integrate nicely into the cylinder diameter. And what I basically did was 3D printed these two cylinders, top and bottom. Incorporated into the cylinder, there's a solid section at the end which is about 10mm long. This is drilled and threaded M4 to suit the shaft of the motor. Beyond that point, it widens out internally to a slightly larger diameter that stops the actual motor jamming up inside. So it's quite fluid in its movement. Okay. The challenge on this is actually getting to a point where you've got the sufficient amount of thread and sufficient amount of cylinder to allow the arm to fully articulate without this thread disconnecting from the cylinder, and also to allow the arm to fully come back into its final position without this jamming up on the end of the motor housing. So it's a little bit of a fine balance, and the only way I could find to get a solution to that was to actually make these mounts that fit onto the N20 motor casing mount, and I could position these pretty much where I wanted them just by drilling through and using 2mm nuts and bolts to hold them in position. And as you've seen from the earlier clip of the truck in operation, it actually works quite well, it's quite effective, and I haven't at this point had any issues with the cylinder becoming disconnected from the motor at that point and the arm basically going floppy. So it does work quite well. I don't think there's really anything else to say too much other than to recap the items I've used on the build. So we've used two 360 full rotation servos for the drive, an N20 100 RPM motor for the cab rotation. It's running on a 10 channel Fly Sky receiver. Usual 20 amp ESCs available either from eBay or Amazon, relatively cheap to buy, not too expensive. And then two 300 RPM N20 threaded motors. They're M4 threaded, that's what controls the arm articulation. And of course the standard little flashing beacon that you can pick up either from RC hobby stores or eBay or Amazon relatively cheaply, but they do, for me, finish the truck off. Again, adds a little bit more realism to it. So if you have any questions or there's anything you feel that I haven't covered sufficiently, please put something in the comments for me. I try to reply to all the comments I receive, positive or negative. It's always good to hear from you guys, get your feedback and your thoughts. Hope you enjoyed the video. As I say, I've tried to keep it relatively brief, relatively to the point, so it doesn't sort of bore people too long. I know there's nothing worse than spending hours watching a video that doesn't actually get to the point very quickly. So hopefully you've enjoyed it. Again, many thanks for tuning in and watching. Your support, your likes, your comments are really encouraging, helps me to keep doing what I'm doing, and hopefully there'll be more content and videos in the future around some of the builds that I've done, and I hope you enjoy them. So many thanks for watching, and I will speak to you again soon, and take care.